The new release of Leantegra CAS-PDS system enables advanced collision avoidance and location tracking features for vehicles in underground mines. The system includes the following components, which you can see here on this demonstration setup. The first one is our Android tablet application for in-cabin installations. It has multiple UI features, which we'll cover a bit later. The second one is the ATEX RTLS anchor for on-vehicle installations. Normally we install 2 devices per vehicle, one at the front and one at the back, but overall we support from 1 up to 4 devices per vehicle. So this is a pretty advanced location tracking device, which again also supports collision avoidance features. For that purpose, we developed our proprietary ultra-wideband based protocol, customized and fine-tuned specifically to the constraints and requirements of collision avoidance in underground mines. This device also has both wireless and wired connectivity interfaces. For the case of wired interfaces, it has RS-485 and CAN bus. We also support the so-called daisy chain wiring between several devices on a vehicle. This is a pretty useful feature when wireless connection between devices is not possible on a vehicle because of some obstacles or vehicle specifics. For the case of wireless data connectivity, we support Wi-Fi, BLE, and also ultra-wideband link protocol, which is also our proprietary protocol to communicate data over ultra-wideband. The next components are about wearable equipment to be used in underground mines. For example, here we have a digital cap lamp enabled with our smart IoT and location tracking features. Such smart IoT features are enabled specifically with these 2 modules. This is our ATEX Mini Ultra-Wideband tag, which can be embedded in a cap lamp or in any kind of wearable equipment for personnel. This is again an ATEX certified module suitable for coal mines. This module is called RTLS locator board. This is the main enabler of all those smart IoT features for digital cap lamps. It supports the BLE RTLS, such as RMA BLE RTLS using the reverse location tracking architecture. It also supports Wi-Fi connectivity, MQTT protocol for data transfers to the server, and other features such as Modbus RTU for collecting and sending the sensor data to the server. For the case of alternative options and lower cost device models, which we also provide as a part of the system. Here you can see another device model which is called Locator Lite. This is a non-ATEX device, still it supports IP67 and other normal and typical requirements for industrial environments. It lacks RS-485 and CAN bus, it also lacks 12 and 24 volt power supply. We have USB here for power supply, but still it can be used for forklifts, smaller and lighter weight kind of equipment, and again this is a bit lower cost device than this one. Overall, our CAS-PDS system supports the following main scenarios or the main features. We support 3 different modes of operations: driving, boarding and parking. For the case of driving mode, we track all nearby objects around the vehicle, such as other vehicles which might approach us, and personnel. The main goal here is to enable really fast detection and tracking of new objects, which might suddenly appear out of nothing. The boarding mode is about loading people onto a vehicle. The main goal here is to enable fast loading of larger amount of people, which can be up to 50 people for larger vehicles. And the parking mode ensures that we do not consume extra power from the vehicle and that the device is turned off. On the settings screen of our Android tablet app, you can see various configuration parameters, such as different options to connect the device using BLE to the Android tablet. The parameters for the vehicle itself, such as vehicle length or vehicle width. You can easily change it here. For example, we can put 5 meters instead of 4 meters, right? Okay. Device placements, it means we can place such devices exactly at the center, or we can move it slightly left or right, which is again configurable here inside the app. For the case of connectivity modes, as you can see here on the screen, we have BLE for wireless connection between the anchors, or RS-485. For the case of RS-485, the master anchor collects all the real-time data from the slave anchor and sends wirelessly using BLE all this data to the tablet. Once again, the system is available for pilot projects and installations already. If you became interested, please feel free to drop us an email. We would be glad to provide you a demo kit or to analyze your project requirements. Thank you.